Hello friends, good evening. Today we are going to discuss JAM previous questions that are asked from Electrodynamics part 3, right? So let us start with the first question. The magnetic field associated with the electric field vector E, that is E is given, E is equal to E0 sin kz minus omega t j cap, is given by. So electric field is given. So what is the magnetic field? The general expression we have studied 1 by omega into k cross, right? K cross E, right? And it is given E here. So 1 by omega into. So this k I can write as k cap divided by k, right? So k cap, right? So k is equal to the vector k is equal to k cap, right? So if it is the modulus, k is the modulus of the k vector, then any vector we can represent as k cap, right? So that is, let me write this as k cap, or you may use the direct formula we have studied 1 by c k cap cross E. You may use this relation also. Okay. So what is 1 by c k cap cross E? That is 1 by c into k cap. K cap is the direction in which the wave propagates. So from the figure it is clear that it is in the z direction. So we can use k cap for the notation of z direction, right? And then k cap into E. Electric field vector is E0 sin kz minus omega t, and its polarization direction j cap. What is k cross j cap? That is minus I cap. So B is equal to minus E0 by C sin kz minus omega t. This minus represent k cap cross j cap, that is minus I cap, right? So minus E0 by C sin kz minus omega t I cap, right? So which one is the option? Option A is correct, right? All right. Minus E0 by 2 sin kz minus omega t I cap. All right. Now let us come to another question. The electric field of a light wave is given by E is equal to E0 I cap sin omega t minus kz and j cap sin omega t minus kz minus pi by 4. So it has two components, one x component and one y component. So Ex is equal to electric field components I can write as E0 sin omega t minus kz and Ey equal to E0 sin omega t minus kz minus pi by 4, right? See, if I am applying some condition here, right? So let me write this. Suppose I am considering t is equal to 0 and z is equal to 0, right? The wave is propagating along z direction. Up z, that means z is equal to 0 means, so what is the component of x? At that time Ex is equal to, see, look into this, t is 0, z is 0. Or you may take another condition. Suppose you are considering omega t is equal to some angle pi by 2, right? You may impose some initial condition. Suppose I am taking omega t is equal to pi by 2, right, and z is equal to 0. So we will get an idea about the shape formed, right? So omega t is equal to pi by 2 and z is equal to 0 means here Ex is equal to sin pi by 2 is 1, right? Here this z is equal to 0. So E0. And what about Ey? Ey is equal to, at that time this z is equal to 0 and pi by 2 minus pi by 4, pi by 4. So sin pi by 4 is 1 by 2 root 2. So E0 by root 2. So amplitude is different, right? That means Ex is greater than Ey, right? So this represents an ellipse, right? So from the condition we already know this is an ellipse. Now we require whether it is a left-handed or right-handed ellipse, right? So suppose z is equal to t is equal to 0. right? Suppose this is my axis. Now you are inserting some other condition. T is equal to 0 and Z is equal to 0. Ex is 0, right? And what about Ey? At that time, this at the time initial time T is equal to 0, Z is equal to 0. This x component is 0, and what about y component? That is E0 sine minus pi by 4. So minus E0 by root 2, right? Minus E0 by root 2. Now, suppose you are considering uh, the condition Z is equal to 0. What is the expression for um, Ey? Ey is equal to sine omega t minus pi by 2, right? E0 sine Z is equal to 0 minus omega t minus pi by 4. Now look into this. This is the expression for y. Now, as the time increases, what happens? What happens to the y component, y amplitude? Omega t increases means this t increases, so the sine value increases. So in the first two quadrants, its value increases, right? So its value increases, sine value increases. That means y component. That means this omega t increases means there is a pi by 4 here. So t value increases means sine omega t minus this omega t minus pi by 4 increases. Omega t minus pi by 4 increases, right? And what about this x value? At that time, this x value that is equal to this z is equal to 0 means ex is equal to e0 sine omega t, right? So omega t increases means so its value increases, x value increases. So from E0 by root 2, this x value going to increase. That means if I go this side, this x value decreases because it is the negative axis. If I go in this direction, this x value increases and this y value decreases. So this means this is a left-handed ellipse, right? So that means this track is going like this. So this will form a left-handed ellipse. So option C is correct, right? All right. Now let us come to another question. For an electromagnetic wave traveling in free space, the electric field is given by E is equal to 100 cos 10 raised to 8t plus kx j cap volt per meter. Which of the following statements are true, right? So first statement, we can check the all the statement separately and then we can say which one is correct or which one is false. So the wavelength of the wave is that is 6 pi, right? So what is wavelength? So from this we can write this omega is equal to 10 raised to 8 and this it is in free space, so velocity is c. Now what is k? K is equal to, we already know that is equal to omega by c, right? K is equal to omega by c, or we can say that is 2 pi by lambda, right? Lambda is equal to that is c by f, right? So that is omega by c, right? 2 pi f is equal to omega. So what is omega? Omega that is given in the question, that is 10 raised to 8, right? Omega t. That's so omega t, that is 10 raised to 8 omega. Divided by c. What is c? 3 into 10 raised to 8. So 1 by 3. K is equal to 1 by 3. What is k? 2 pi by lambda. Then what is lambda? 6 pi. So first statement is correct, right? And the second statement is the corresponding magnetic field is directed along the positive z direction, right? Is it correct? So the electric field polarization is that is along j cap, right? And what is the direction of this wave propagation? The wave is propagating along k, right? That means it is in the x cap, right? Because kx plus 10 raised to t. So we already know this expression for the wave executing in positive x-axis, that is E0 cos omega t minus kx. And what is the expression? E is equal to E0 cos omega t plus kx is given. So it is in the negative x direction, right? So this wave represent the wave propagating in the negative x direction, right? Alright. So the corresponding magnetic field, the wave is propagating along the negative x direction. So negative x direction means the wave is along this direction. Right. What is the direction of electric field? Electric field is along j cap. Then what would be the magnetic field direction? Right. Magnetic field direction will be, so what is the direction of magnetic field? So look into this, this wave vector direction is, that is E cross B direction should be, E cross B is the direction of the propagation of the wave, right? So that should be minus x cap. So what is the direction of this electric field? That is j cap, right? So j cap cross something is minus x cap. Then it should be minus z cap, right? Minus k cap. So the magnetic field should be in the negative z direction. Then only we will get the wave propagation along negative x axis, right? So but it is given, it is along positive z. We got it is negative. So this statement is not correct. If wave is propagating along negative x direction, pointing vector also in the negative x direction. It is not along the direction of magnetic field, right? So the wave vector is propagating in the same direction the energy is transported, right? So the wave vector, pointing vector is along negative x direction, not in the z direction. The wave is linearly polarized. That is true because the wave has only one component, right? Only one amplitude, that is E is equal to E0 j cap, right? There is no y component. So it is not a circular or elliptical. To come out a circular or elliptical polarization, we must need two components, right? It has only one component. So it should be linearly polarized. So option A and D, that is correct. This is a multiple answer type questions. Okay, so A and D is correct. Now let us come to another question. The power radiated by the sun is 3.8 into 10 raised to 26 watt and its radius is given. The magnitude of the pointing vector in watt per centimeter square at the surface of the sun is, right? So what is the pointing vector? Pointing vector is equal to, right? Pointing vector is equal to intensity, that is equal to power per area, right? What is power? Power is equal to 3.8 into 10 raised to 26 divided by what is area? Area is equal to, that is equal to, here radius is given, right? That is 7 into 10 raised to 5. But we need the answer in centimeter square. So we have to convert this into centimeter square, right? So we have to convert the radius into centimeter, then we have to square is, right? So that is pi r square. All right. So sun is radiating energy which has a spherical symmetry, right? So 4 pi r square, 4 pi into this I can write as 7 into 10 raised to 8, right? 10 raised to 8 and meter, that much meter. So we can multiply with 100 and then we can write it as centimeter. So it's whole square. So when you do this, you will get the answer, right? The approximate answer is 6174 watt per 6174 watt per centimeter square, right? So this will be the answer. All right. Now let us come to another question. A 1 watt point source at origin emits light uniformly in all directions. If the units for both the axes are measured in centimeter, then the pointing vector at a point 110 in watt per centimeter square is, right? So again the answer is we need to find the pointing vector, that is power per area, right? Its direction is r cap. So power divided by a point source, right? A point source means that is 4 pi r square. 4 pi r square. It is radiating in all side which has a spherical symmetry. And what is r cap? R cap is equal to a vector divided by its modulus. So that is p divided by 4 pi r cube r vector. Now this is the position vector. So what is r vector? R vector is equal to say, so the answer is given ex cap and ey cap. I cap and j cap are representing with ex cap and ey cap. So let me write this is ex cap plus ey cap. There is no z component here, so 0 ez cap, right? And what is r modulus of this? That is square root of 1 square plus 1 square, that is root 2, right? So let me substitute all this value here, that is p by 4 pi then root 2 whole cube into what is r? R is equal to ex cap plus ey cap. So this is equal to p divided by 4 pi, that is 8 pi, this is 2 root 2, so 8 pi root 2 ex cap plus ey cap, right? All right, so this will be the answer, 4 pi root 2 8 pi root 2. So option A is correct, right? 8 pi root 2 ex cap plus ey cap. All right, and power is given here, that is 1 watt. So P we can replace with 1. All right. Now let us come to another problem. The electric field of an electromagnetic wave is given by E is equal to 2 k cap minus 3 j cap 10 raised to minus 3 sine 10 raised to 7 x plus 2y plus 3z minus beta t. The value of beta we need to find, right? What is the value of beta? Beta is 10 raised to k, right? So the electromagnetic wave C is light is given. And what is this k vector? So we can compare with the general equation. What is k vector? K is equal to k vector is equal to k dot r format. That is 10 raised to 7 into I cap plus 2 j cap plus 3 k cap. Alright. And what is this omega? Omega is equal to 10 raised to 7 beta. Right. Now what is mod k? What is k? 10 raised to 7 into square root of this 3 square plus 9 plus 4 13 plus 1, that is root 14, right? Now we already know C is equal to omega by k, right? C is equal to omega by k, that is C is equal to 3 into 10 raised to 8 is equal to what is omega? 10 raised to 7 beta divided by 10 raised to, so that is in terms of C we need to write 10 raised to 7 root 14. So 10 raised to 7, 10 raised to 7 cancel. So what is beta? Root 14c, right? So which one is the option? Option A is correct, right? All right. Now let us come to another question. An infinitely long solenoid with its axis along k cap carries a current I. In addition, there is a uniform line charge density lambda along the axis. S is the energy flux, right? That means it is representing a pointing vector in cylindrical coordinate. Then what is the direction of S? S is along rho cap, S is along k cap. So we already know the pointing vector has the dimension of, pointing vector is defined as E cross B. So E cross B is the direction of S. So we have to identify for a long solenoid what is the direction of this E and B. We already know for a solenoid the magnetic field is along the axis, right? So it has the direction of k cap, right? And what is the direction of C? The magnetic field is along k cap. And what is the direction of electric field? So electric field is radially outward, right? So that is rho cap, right? So it is radially outward, right? So what is the direction of pointing vector? So rho cap cross k cap. E cross B direction is rho cap cross k cap. So which one is the option? Option D is correct, right? All right. Option D is correct. Now let us come to another question. Consider electromagnetic plane wave E that is E0 I cap plus Bj cap cos 2 pi by lambda Ct minus x minus root 3 y, where lambda is a wavelength, c is the speed of the light, and b is a constant. The value of b that we need to find. So we already know the k vector from here. What is the k vector? So k cap we need to find. What is k cap? So k cap is k vector. So you can identify k vector. So it is a omega t minus kx format, right? Omega t minus kx format. So what is k vector? That is I cap minus root 3 j cap, right? And what is this polarization direction? N cap. So n vector. So k vector we already know, that is n vector also we can write. Polarization vector, that is I cap plus bj cap, right? So the wave is propagating along this direction, and the polarization direction is perpendicular to it, right? That is the nature of the transverse wave. So we must the condition should be k dot n should be 0 for an EM wave. The polarization direction that is in dot product with this wave vector, that should be equal to 0 because they are perpendicular to each other. So that is 1 minus b root 3 is equal to 0. That is b is equal to 1 by root 3. So 1 by root 3, that's value you can write as answer here, right? All right. Now let us come to another problem. The wave number of an electromagnetic wave is incident on a metal surface is, so wave number is given. We have already studied electromagnetic wave in conductors. The wave vector that is complex in nature, that is alpha plus I beta, and we have studied this in that such case skin depth is 1 by beta, right? This all we have studied in theory. We have derived the expression for skin depth, right? That is 1 by, what is beta here? Instead of I beta here 750 I, so beta is 750. So that much meter, right? So I can write this in the skin depth of the metal is, specify your answer in millimeter, right? So to convert it in millimeter, I can multiply with 1000. So 1000 by 750 millimeter. That is 1 point something millimeter, right? That you have to write as answer here, right? Now let us come to another problem. A collimated beam of laser light of wavelength 540 nanometer is normally incident on a smooth glass slab placed in air. Given the refractive indices of the glass and the air is 1.47 and 1 respectively. The percentage of light in intensity reflected back. So this percentage of intensity, that is E0R divided by E0I, right? That we have to multiply with 100. This is the amplitude of the reflected wave, and this is the amplitude of the, so intensity, that is the square of this, that we have studied as n1 minus n2 divided by n1 plus n2 the whole square, right? What is n1? n1 is the air refractive index, that is 1 minus 1.47 divided by 1 plus 1.47 the whole square. So when you do this, you will get a 4, right? 4%, right? So option B is correct, right? Right. Sorry, it is not 4%, it is 3.6%, because 1 minus 0.47 divided by 1.47. It is not near to 5. It is below 4. So 3.6, right? 3.6%. All right. Now let us come to another problem. A plane electromagnetic wave of frequency 5 into 10 raised to 14 Hz, amplitude 10 raised to 3 volt per meter, traveling in a homogeneous dielectric medium of dielectric constant 1.69 is incident normally at the interface with the second dielectric medium of dielectric constant 2.25. The ratio of the amplitude of the transmitted wave to that of the incident wave. So the light is falling with a frequency and amplitude is given, and it is incident on a medium with a dielectric constant. Okay, and a second dielectric medium has the 2.25. The ratio of the amplitude of transmitted wave to that of the incident wave. So we need to find E0t divided by E0i, right? We need to find basically E0t divided by E0i. So we have studied an equation for this, that is N1, right, 2N1 divided by N1 plus N2 whole square. So not whole square, this much alone, right? So this is the equation we have studied, right? And we have studied E0R by E0T also. Okay, that we need not. We have studied E0R, reflected wave divided by E0I, that is N1 minus N2 divided by N1 plus N2 the whole square, right? But the refractive index not given in the question. So instead we have the dielectric constant here, right? So we have already studied, it is a, so we studied N1 is equal to root epsilon R, right? So this is the first medium, and here root epsilon R. So this is the first medium, so epsilon R1 plus root epsilon R2. So 2 into, so first is 1.69, 1.69 divided by root 1.69 plus root epsilon R2, that is again epsilon R2 is 2.25. So it was all perfect square root, so you may simplify this. Alright, that is the correct answer. When you solve, you will get an answer as, let me check, so 0.93, 0.93. Alright. Now let us come to another problem, that is, consider the normal incidence of a plane electromagnetic wave with the electric field is given by E is equal to E0 exponential k1z minus omega t x cap over an interface at z is equal to 0, separating two media, right? Wave velocities v1 and v2 and a wave vector k1 and k2 respectively, as shown in the figure. The magnetic field vector of the reflected wave is. So it is given that a magnetic field vector that is reflected here. So we already know that is the wave is given, right? Let me write the wave. E is equal to E0, right? E is equal to E0 e raised to k1 z minus omega t, and it is polarized in the direction x cap, right? Electric field vector. So look into this diagram. This electric field, the magnetic field is this wave is propagating along the z direction. So this is the propagation direction, and the electric field is along this x cap. So this is my electric field direction. So magnetic field, that is along y cap direction, right? So we already know when it hits the interface, then the reflected wave traces path like this. So it has a 180-degree phase difference. B has 180-degree phase difference. So but we already know that is E0 by in this medium velocity is V1. So B0 is equal to E0 by V1. So 180-degree phase difference, right? So that means E raised to, and it is reflected to the same medium. So there is no change for wave vector, that is k1z, but it is propagating after reflection, propagating in the negative z direction. So minus k1z, z become negative, minus omega t. And what about polarization? Polarization direction is x cap here. So for the incident wave, look into this diagram. For the incident wave, it is the electric field is that is along magnetic field is along this direction, right? So after reflection, this wave is going like this, right? So the magnetic field is polarization changes to 180-degree out of phase. So this is representing this x cap, and here it is y cap, and this minus y cap. The magnetic polarization changes to minus y cap direction. So I can represent E is equal to minus E0 by V1 minus E0 by V1 e raised to minus K1Z minus omega t, right? So which one is the option? Option is minus E0 by V1 e raised to, right, we have a I out. This I forgot to put a complex notation. Minus K1 is minus omega t. Right, direction is minus y cap, right? So here we have a y cap. All right, so look into this. So option is C, right? Now let us come to another problem, that is using a battery of 10 picofarad capacitor is charged to 50 volt, and then the battery is removed. So you are charging a capacitor and then you are removing the battery. After that, a second uncharged capacitor connected to the first capacitor in parallel, right? Suppose you are charging. What is the charge? Q is equal to CV. That means you are charging to 50 volt. That is 10 into 50. That is 500 picofarad. Now you are going to connect this capacitor. Suppose you are going to connect this capacitor parallel to another capacitor, right? Now what is the constant? It has already charged. That charge is not going. Charge may flowing from one capacitor to another up to the potential is constant, but not going to change the charge. Charge may be fixed, right? So suppose after flow of charges, here it is Q1 and here it is Q2, and the potential here become V and here it become V, right? So potential become a constant, right? So what is the final capacitor is its capacitance is C1 and its capacitor is C2. Okay, so we can write Q is equal to Q1 plus Q2. That is the equation we have, right? Charge remains constant. And what is this Q, right? So let me write this total charge is 500. So it is picocoulomb, right? It is not farad. 500 picocoulomb equal to, what is Q1? Q1 is equal to C1V, right? After charging, the potential will be constant. That is C1, right? C1V. What is C1? C1 it is given, right? That is 10 into, and what is the capacitance of this capacitor, right? So Q1 is equal to CV, it is 20 volt, right? The voltage across the one capacitor is given, that is 20 volt. That should be equal to other capacitor because we are connected in parallel. So 10 into 20 plus, and the second capacitor, that value we don't have, and the potential should be same, that is 20. So this 10 into 20, that is 300 minus 500, that is again 200, right? So this is 10 into 20, right? 10 into 20, first capacitor is 10 into 20, that is 200, right? I am sorry, 200. 500 minus 200, that is 300. 300 by 20, that is equal to C2, that is 15 picofarad, right? So answer is 15. Now we have another question, that is the last question. In an experiment on charging of an initially uncharged capacitor, an RC circuit is made with a resistance R is equal to 10 kilo ohm, and the capacitor C, that is 1000 microfarad, along with The voltage source is 6 volt. The magnitude of the displacement current through the capacitor 5 seconds after the charging has started. So charging has started means growth of charging. This is a CR circuit. So let me use this I is equal to I0 1 minus e raised to minus t by CR. Right, we need to find the magnitude of the displacement current. Right, I we need to find the what is the current in through capacitor. That is nothing but that is displacement current. Right, we have already discussed in Maxwell formula. So that I we need to find, but I0 is V by R, right, along with a voltage source. So that is V by R. So I0 is maximum current is V by R. So that is 6 by 10 into 10 raised to 3 into 1 minus e raised to minus after 5 seconds. So 5 divided by what is C? C is equal to 1000 microfarad is 10 raised to minus 3. Right, 1000 into 10 raised to minus 6. That is nothing but that is 10 raised to minus 3. And what is R? Again, it is 10 into 10 raised to 3, that is 10 raised to 4. You can simplify this. That will be the displacement current. Alright. So this all about this section. In the next section, we will start with the net previous questions. Okay. Thank you.
CEED Physics Clinic is a unique career endeavor, provides organized coaching for UGC-CSIR NET and IIT JAM. We provides live interactive classes, online exam series, and organized study materials. For more details, contact 9388877666.